So we have to try doing out this problem. This is basically regarding an 8-point IDFT using DIT technique. And this is again a problem that we have looked into before, at least in the theory class. And we know the answer is going to be for this particular case, that is 1, 2, 3, 4, 4, 3, 2, 1. So let's try to do our best in this regard. So if we are trying to do this particular problem, n will be equal to 8 as clear and evident from the problem. Then m will be equal to 3. Then you have to determine the butterfly diagram, which is again the same concept. You are using the DIT butterfly. So AB, this dual factor comes here. This becomes -1. So this will be A plus B W and K. And this will be A minus B W and K. And that's with regard to the butterfly diagram. Then the order of the stages will be 8 point first, preceded by 4 point, and then preceded by 2 point. This will make up the 3 stages. This will be done 2 raised to 0 equal to 1 time. This will be done 2 raised to 1 equal to 2 times. This will be done 2 raised to 2 equal to 4 times. Okay, so that is with regard to this particular thing. Again, the twiddle factors which we have to determine, twiddle factors will be as follows. You have to use 8-point DFT. So the twiddle factors we already know, Wn0 to Wn minus of n by 2 minus 1. This will be the required twiddle factors. So please note over here. So this will be W80, W81, W8, 8 minus 1, sorry, 8 minus 2, and W8 minus 3. So we'll have to determine these twiddle factors. So W80 is already 1. W8 minus 1 will be cos, or we'll do it this way, e raised to minus j 2 pi into minus 1 by 8, which is equal to e raised to plus j pi by 4, which is equal to cos pi by 4 plus I sin pi by 4. So this will be like 0.707 plus 0.707 I. Then we have W8 minus 2, which will be e raised to minus j 2 pi into minus 2 by 8, which will be e raised to minus j, sorry, plus j pi by 2, which will become cos pi by 2 plus I sin pi by 2, making it I. And then the last twiddle factor will be like and we have just completed the twiddle factors, that is W3 minus 8 minus 3 will be minus 0.707 plus 0.707 I. And then we have to determine the input in the bit reversed order. So we have 8 inputs out over here, so which will be x of 0, x of 1, x of 2, x of 3, 4, 5, 6 and 7. We write the binary version 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. We reverse the bits, so this becomes 0, 0, 0, this becomes 1, 0, 0, this becomes 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 0, 1, 1 and 1, 1, 1. So this will be like 0, this will be like 4, this will be like 2, this will be like 6, this will be like 1, this will be like 5, 3 and 7. And we have x of 0, 4, 2, 6, 1, 5, 3 and 7, which will be the bit reversed inputs. Now we'll move ahead to solve this particular problem. You can carry it on your own, and just understand that you are supposed to get the output as 1, 2, 3, 4, 4, 3, 2, 1, and in the normal order. So your input sequence that we have determine the bit reversed order over here should be written over here. So this will be the 2-point DFT. And in the 2-point DFT, so when we speak about the twiddle factors, like it was already mentioned for the normal DFT problems, you find the twiddle factors from this particular stage 8 point, and from this automatically you can determine W40, which is 1, W4 minus 1, which will be equal to W8 minus 2. So you have the answer over there, which is I. And for 2 point you need another twiddle factor W20, which will be equal to 1. So you can get these twiddle factors and you can start solving the problem. So you substitute these corresponding input terms that you have over here in the bit reversed order, and you start solving the problem for a 2-point DFT. Then you have the 4-point DFT. You'll be combining these two butterflies to form this 4-point DFT. Just remember the twiddle factor difference over here. This will be W40 and W4 minus 1. And similarly at the last point you have the 8-point DFTs, where you will have 4 butterflies using W80, W8 minus 1, W8 minus 2 and W8 minus 3. And you'll be performing the operation over here, and by that means you will be getting the output over here. Again, when we speak about the output, we will have a certain problem here. We won't get it as a perfect integer, as with no decimal values. For example, in our question we have the values as 1 2 3 4 4 3 2 1. It could be possible that you could get a value like 0.99999 as your first term and 1.98 something as your next term. It is possible. So whatever it is, that is because of the computation involved when we go for the number of places in terms of decimal terms. And note the fact that the answer to be obtained is 1 2 3 4 and 4 3 2 1 at the output. So you can try doing this particular problem on your own and get the answer.